Yeah. How will you? Okay. Thin films. Okay. See, this is when light is incident on the thin film. What happens now? It undergoes reflection and refraction. Then again it strikes like this. Okay. So then it reflects and refracts. Here again the ray comes out. Here again undergoes reflection. Again the ray comes out like this. Like this. Okay. So like this. Here this is the incident ray, this is the reflected ray, this is the refracted ray, and ray again undergoes reflection and transmission. Here again it transmits, again reflects, and again it will transmit like this. So now this is called path difference. This is the angle of incidence. This angle of refraction. Angle of incidence always equal to angle of reflection. So this is R, this is also R. R, this is also R. Okay. So ray comes out, this is R dash. So again R means this is also R. Now it comes out with some other angle, R double dash. Okay. You can also see. So these are transmitted, this is the reflected. So A, B, C, B, E, F, G, H. This is transmitted. This is reflected. Okay. Now, due to reflected interference, due to reflected light. Now, first, interference due to reflected light. Interference due to reflected light is condition for constructive in the bright. For constructive, path difference delta x, okay, is how much? Is equals to 2n minus 1 into lambda by 2. That is 2 mu t cos r equal to derivation raised to మనకు అవసరం లేదు. ఇది కండిషన్ ఫర్ బ్రైట్ constructive where n equals to 1, 2, 3 and so on. We voted for destructive. This is constructive and maxima. Next, destructive. This is what? Minima. Okay. This is how much? 2 mu t cos r is equals to n lambda. This is for destructive. Okay. Where n equal to 0, 1, 2, 3 and so on. The destructive. Okay.
So what is the path difference for destructive?
Huh?
Got it.
అదే transmitted system లో transmitted the దీంట్లో in transmitted system లో 2 mu t cos r is equals to n lambda. This is for maxima. Ulta. దీనికి ఉల్టా అవుతుంది. ఓకే, గుర్తుపెట్టుకోండి. Equals to
That is cos I, sir. Cos R.
lambda by 2. This is for cos r.
सर पाथ डिफरेंस क्या है?
Where is the path? This one.
डिफरेंस है
Delta x equal to n minus 1 into lambda by 2. So condition for maxima is 2 mu t cos r equal to 2n minus 1 into lambda by 2. Minima is this formula. You remember, whatever the condition for maxima and minima in the reflection, exactly ulta for transmission case.
यस
So derivation is waste. We are not doing, waste of time and energy. This itself is out of syllabus, but we are discussing is included.
Sir, for constructive maxima, delta x is equals to n lambda, no, sir?
Then one comes out. Okay.
2 म्यूटी cos r दिया सर डेल्टा x
Cos r is 2n minus 1 into lambda by 2. This is for maxima. Minima ku 2 mu t cos r equal to lambda. Suppose
sir,
for
okay.
not normal incidents, and if ray incident normally, then I will be 0, R will be 0. So R 0 होते क्या होता? Cos 0 is 1. So 2 mu t equal to 2n minus 1 into lambda by 2. Destructive क्या होता? 2 mu t. A cos r equal to n lambda. The brain punches. Okay.
Sir, do we have even conditions and applications, sir, of principle?
Condition for
Interference, sir, conditions and applications.
yeah. అయిపోయిందా? రాసిన ఫస్ట్
Yes.
రాసిన తర్వాత రాయండి. For normal incidents I will be 0, R will be 0. Then it will become 2 mu t equal to 2n minus 1 into lambda by 2. Maxima n lambda minima. For reflected light. Okay? 2 mu t equal to n lambda, 2 mu t equal to n minus 1 lambda by 2. Maxima. This is for what? Transmitted. Question అడుగుతారు ఇక్కడ ఓకేనా అంతే ఏం అవసరం లేదు టైం వేస్ట్ దీనిలో ఒక లెక్క కూడా ఇవ్వలే నేను చెప్తాను మీకు కంగారు పడదు. ఇప్పుడు మనం ఎక్కడున్నాం మనం ఎక్సర్సైజ్ 3 చేస్తున్నామా ఎక్సర్సైజ్ 3 చేసాం రా అయిపోయిందా
No, sir.
ఎక్సర్సైజ్ తొందరగా చేసి ఈ థిన్ ఫిల్మ్స్ లెక్కలు దీంట్లో మన టెక్స్ట్ బుక్ లో దీంట్లో లేవు ఉంటే వర్క్ బుక్ లో ఉన్నాయి ఒకటి రెండు చూద్దాం Okay. Now problems. Problem number 20. Indra?
Yes.
20. Exercise 3, page number 323 page. వాళ్ళ థిన్ ఫిల్మ్స్ ఏంది డెరివేషన్ చేసిన ఎవరికి ఎలైట్ వాళ్ళకు కానీ డెరివేషన్ వేస్ట్ దాన్ని ఎవరు అడగరు అర్థమైందా దానివల్ల ఏం యూజ్ లేదు కానీ టైం ఉండే వాళ్ళకు ఇక్కడ వాళ్ళ ఎక్సైజ్ 2 అడిగారు డౌట్లు ఒకటో రెండో అడుగుతారు ఎక్సైజ్ 3 కూడా చేస్తారు ఒకటి రెండు అడుగుతారు టైం చాలా ఉండే ఏం చేయాలి బోర్ వచ్చింది డెరివేషన్ చేసిన అర్థమైందా అట్లా సో మీరు లెక్కలను చేస్తే డెరివేషన్ నో యూజ్ దేనివల్ల అది ఏం లేదు అది ఐపీకి లేదు దేనికి లేదు సో కాబట్టి అవసరం లేదు అలా టైం ఉంది కదా చేసింది సరే పేజ్ నెంబర్ 323 క్వశ్చన్ నెంబర్ 2 వాళ్ళ వర్క్ బుక్ అవన్నీ చేసేది మీరు కూడా అన్ని చేయాలి ఏది వదలదు ఓన్లీ డౌట్స్ అడగదు క్వశ్చన్ నెంబర్ 20 చూడు ట్రాన్స్పరెంట్ గ్లాస్ ప్లేట్ ఆఫ్ థిక్నెస్ ఎంత 0.1 mm 0.5 mm and refractive index 1.5 placed in front of one of the slits in double slit experiment. The wavelength of light used is 6000. Okay. Ratio of maximum to minimum intensity in the interference pattern is 25/4. So I maxima by I minima is 25/4. Okay. So transmitted light to what? Incident light ratio. చూడు question what is asking design. Now this is the two slits. Okay, this is the screen. Okay, this is D. This is small d. Right? This is point source. In front of one of the slit, you are placing a mica sheet. The light which is incident on this is I1. Light coming from this other slit also I1. But light coming from this slit is, this sheet is I2. Right? So this I2 and this I1 both are interfering and forming what interference on the screen. So I maxima to I minima is this. What is the I1 by I2 is asking. Cheppu. First, what is the path difference introduced by this? Is given any chadu? I maximum by I minimum is 25 by 4. Now the question is, so what is the path difference introduced? Path difference introduced.
Open చేసినావా? Okay.
Path difference introduced by mica sheet. Path difference introduced by mica sheet and delta x equal to t into mu minus 1. Correct?
Yes.
It is path difference. So phase difference enta? First, phase difference is 2 pi by lambda into delta x. Delta x at t into mu minus 1. So then intensity I2 from this. అవును ఇక్కడ డైరెక్ట్ వస్తుంది కదా ఎంత అక్కర్లేదు ఎంత చెప్పు ఐ మాక్సిమం బై ఐ మినిమం ఎంత I1 ప్లస్ I2 బై కదా I1
Root I1 plus root I2.
రూటా
Yes.
ఇది హోల్ స్క్వేర్ కదా
Yes.
సో root I1 plus root I2 by root I1 minus root I is
Five
by కదా
5 by 2.
ఎంత వస్తుంది చూడు సో 2 root I1 plus 2 root I2 is 5 root I1 minus 5 root I2. ఎంత 3 root I1 7 root I2 కదా ఇంతేనా సో root I1 by I2 is 7 by 3. So I1 by I2 is 49 by 9.
Sir, it should be 3/7 now.
Huh? 3/7. And 3/7. I1 is more కదా ఇన్సిడెంట్ ట్రాన్స్మిటెడ్ తగ్గుతుంది కదా whatever ratio of intensity transmitted to incident అంటే 9/49 transmitted is I2 కదా incident is I1 కదా
Yes.
1000 is there ఇచ్చాడు So I2 by I1 is 9/49. అదే ఆన్సర్ సెకండ్ Next 21. In the YDAC, using monochromatic light of wavelength lambda, the path difference corresponding to any point having half peak intensity. Half peak intensity. So, resultant intensities, peak intensity and the 4I not kada? Half
Yes,
peak intensity and 2I not kada? And the 4I not cos square 5/2. There, so the cos square 5/2 is half. Cos 5/2 is plus or minus 1/√. Right? So 5/2 and the 45. 5/2 45 and 5 9. So 590 కావచ్చు multiples అంతేనా so 5 equal to pi/2 3 pi/2 5 pi/2 ఇట్లా so అంటే the 5 is odd multiples of 5/2 కదా so since you know 5 equal to 2 pi by lambda into delta x కదా so you know that since 5 equal to lambda into delta x అంటే 5 ఎంత 2n minus 1 into pi/2 is equal to 2n minus 1 is 2n plus 1 అంటే n equal to 0 1 2 3 కదా n plus 1 కూడా వస్తుంది into pi/2 equal to 2 pi by lambda into delta x pi cancel so delta x equal to 2n plus 1 into lambda by 4. Second option. Good.
So why did you take 2n plus 1?
2n plus 1 అంటే n equals 0 1 2 3 n equals 0 పెడితే 0 plus 1 into pi/2 n equal to 1 పెడితే 2 into 1 2 plus 1 3 pi/2 అంటే 2n plus 1 is also right 2n minus 1 right when you write 2n minus 1 n starts from 1 2 3 we cannot put 0 అర్థం కాలే
Understood, sir.
suppose if I put 2n minus 1 if I put n equals 0 you will get 0 minus 1 వస్తుంది అంటే minus pi by 2 అర్థమైందా?
Yes, sir.
సో ఇక్కడ n equal to ఏంటి? ఇక్కడ n equal to 0, 1, 2, 3 and so on. If you use 2n minus 1, that is also correct. But you have to use n equal to 1, 2, 3, 4. 0 you cannot use. But that is also right. This depends upon n value. 20 seconds. Chalu. Kali fast ga. Udrai workbook la కొన్ని లెక్క చేద్దాం. Third, 22nd. Hence, double slit experiment is carried out with 2 thin sheets of thickness 10.5 micrometer. So, with 2 thin sheets of thickness, okay, thickness of the child 10.5 micrometer, and refractive index of mu1 is 1.5, mu2 is 1.4. Okay, covering the slits S1 and S2 respectively. The white light of range 4000 to 7800 is used. Then which wavelength will form minima exactly at the center of the screen? Okay. Minima exactly at the center of the screen. Now you will have this is the screen, these are the 2 slits. You are using 2 mica sheets. Whatever to do, the light coming from both the mica sheets. He's saying that what is the shift produced by first mica sheet? That is shift due to first slit. What is the path difference? The path difference due to first slit minus path difference due to second slit. Both the what here? Mica sheets will introduce path difference. So difference of the path difference should be equal to emanadu. At the center, you want to have minima exactly at the O. Minima gavalandi. Minima into what is the condition for minima? 2n minus 1 into lambda by 2. What is the delta x? T into mu1 minus 1. This is T into mu2 minus 1. Is equal to 2n minus 1 into lambda by 2. So 2 into mu1 minus mu2. 2n minus 1 into lambda by 2. So 2t mu1 minus mu2 by 2n minus 1 equal to lambda. Right? Now you keep substituting. 2 thickness at the chart 10.5 micrometer and minus 6. Mu1 1.5 minus 1.4. 0.1 by 2n minus 1. Now what you will have? 10.5 into 2 and 21. So lambda then the 21 10 to the power of minus 7 by 2n minus 1. 21 into 1000 and divided by 1000. So it will become 21,000 angstrom.
Yes, sir.
Then you put it n equal to 1. When n equal to 1, what is the lambda? 21,000 angstrom. N equal to 2. What is the lambda? 2 2 is the 4 minus 1, 3. 21,000 by 3. And the 7,000. N equal to 3. 21,000 by
3,000.
2 3 is a 6 minus 1, 5.
5.
5 and 10 the 4. Okay.
4,200.
2.
0 0. Kada?
Yes.
4,200. And the wavelength ranging from 4,200 to 7,000 undi kada?
Yes.
So after the fourth option. And you can use all these wavelengths such that the net path difference at point O can have minima. This is a minima condition. Only when you use a wavelength, use all wavelengths. 21,000 is not in visible range kada. So visible range lo undi 4,200 and 7,000. It is violet, it is red. 23 yesterday we finished.
Can you explain how you got the first equation, sir, of difference of path difference equal to 2n minus 1 lambda?
Yeah. Path difference introduced by 1 mica sheet. చెప్పిన మీకు నిన్న పాత్ డిఫరెన్స్ అంటే ఇది ఇట్లా మైకా షీట్ ఉందనుకో. సో when light ray is passing through the mica sheet, this is of refractive index mu. There is certain time taken by light to travel through mica sheet, and the time is equals to distance traveled by the light in the mica sheet is t, thickness, by velocity of light in the mica. You know, mu equal to c by v, and v equal to c by mu. So ఏమైతుంది?
Mu into t by c.
Is t time. So during this time, what is the distance traveled by light ray in air? This is in air.
Mu into t.
So distance traveled in air is c into time. C, time and delta mu t by c. So path, this is called in the optical path in air. So what is the distance traveled in air during this time? Mu t. But actually another ray which is traveling through mica sheet and only t. So what is the difference in that distance between these two? Mu t in air and t in this thing, t into mu minus 1. This is the path difference introduced by the mica sheet. So path difference introduced by one mica sheet is this, second mica sheet. So these two will introduce in opposite, because one mica sheet is in front of S1, another is in front of S2. So S1 mica sheet will bring all the fringes up. S2 mica sheet will bring all the fringes in down. So difference should be equal to emundali at the point O. At point O, emundali Minima. Minima, what is the condition for minima? 2n minus 1 into lambda.
2n minus 1 lambda. Yes, got it.
Next 24th చూడు. 24th చదవండి. Okay? Question 24 చదివిండ్రా? Next experiment, the slits are 2 mm apart. Slits ఎంతనంట? 2 mm. Question number 24. ఇదంతా ఒకసారి తీయనుంటుంది. తీసేసి నీట్గా తుడిచి బోలని నీట్గా సరిపోయి స్నానం చేసి కదా ఏం సమస్య కదా. So what he's telling, these two what are illuminated by wavelengths in the channel. Lambda 1 is 12,000. Lambda 2 is 10,000, correct? At what minimum distance from the common central fringe on the screen? 2 meters. Screen into the 2 meters. From the slit, a bright fringe on the screen will form a bright fringe on one of the white side. Bright from one interference pattern coincide with the bright fringe of other runner. Ever question? Bright fringe on the screen from slit will fringe from one. Okay. Question is, now this is the interference with the okay. Light is coming from this. Light is also coming from this. Okay. So both are producing their own interference. Both are producing their own interference. When both are producing their own interference, what is telling? Bright fringe of lambda 1. So let us say, what is the bright fringe formula? Y equal to n lambda d by d. So bright fringe of first wavelength, and bright fringe of second wavelength is n2 lambda 2d by small d. These two bright fringe of coincident, both the bright fringe. Let us say nth bright fringe of lambda 1 coincide with n plus 1th of lambda 2 అనుకుందాం. ఓకేనా? పెట్టినా?
So how is that equal to each other?
లేకుంటే N1 of bright fringe of first one, N2 of bright fringe of second one coincide. But coincide కావాలి రెండు. So let us say y1 equal to y2. అంతేనా? అంటే ఏమైతుంది n1 lambda 1 d by small d should be equal to n2 lambda 2 d by ఎంత b. కరెక్టేనా? So n1 by n2 is lambda 2 by lambda. కరెక్టేనా? lambda 2 అంటే 10,000. ఇది 12,000. 2 5s are 2 6 అంటే 5 by 6 కదా. అంటే fifth bright fringe of lambda 1 coinciding with what? Sixth bright fringe of lambda. So therefore fifth bright of lambda 1 equal to sixth bright of
lambda 2.
lambda. What is the fifth bright fringe of lambda 1 ఎక్కడ ఉంది చెప్పు? Is asking position. 5 lambda 1 d by d. ఎంతరా? 5 lambda 1 ఎంత? 12,000. Angstrom అన్నాడు అంటే -10. d ఎంత ఇచ్చాడు? 2 మీటర్. స్మాల్ d is 2 mm అన్నాడు. పెట్టనా? ఎంత అవుతుంది? 12 5s are 60. ఇదంతా 10 to the power of -7 by 10 to the power of -3. So
lambda 1 is 10,000.
6 into 10 to the power of -3 అంటే 6 mm. ఉందా అసలు? ఇది ఏమంటావు?
No, sir.
Sir, वो फिफ्थ ब्राइट फ्रिंज लैम्बडा 1 equals to सिक्स वो कैसे दिया सर?
వచ్చిందా? n1 is 5, n2 is 6.
अच्छा ओके.
n1 belongs to lambda 1. Lambda 1 is this. n2 belongs to lambda 2. Lambda 2 is this.
Okay.
Sir, why is the minimum distance for the sixth bright fringe of lambda 2 also not the answer?
Minimum.
Yes, so like minimum distance we took out for fifth bright fringe of lambda 1 is 6 mm.
तो सिक्स भी निकाल सकते हैं ना?
అక్కడ ఆ పాయింట్ దగ్గర రెండు కోయిన్సైడ్ అయితే both the bright fringes will coincide.
Yes, I got it.
सिक्स को भी सेम रहता बोला था.
Next देखो 25. In Young's interference experiment, yellow light is composed of two wavelengths distinct between the two states. The small d is 1 mm and the capital D is 1 meter. Up to what under can fringes be seen? Fringes చూస్తూ ఉంటుంది అంతేనా? To what order the fringes can be seen? What order అంటే maybe nth order or nth order of lambda 2. Lambda 1 ఎంత ఉంది? 58 90 కదా. Lambda 2 58 90. అంటే up to what order can be seen అంటే up to what bright fringe you will get. Beyond that you won't get it, right? let us say nth bright fringe. Nth bright fringe of lambda 1 coincide with because this is lambda 1 is less, no? Lambda 1 is less కాబట్టి ఇది ఎక్కువ ఉంటుంది n plus 1th order. ఇది nth bright fringe of lambda 2 wavelength ఎక్కువ ఉంది కదా, ఇది తక్కువ ఉన్నది. So you have to find out in what order you will get it. అంటే n plus 1 into lambda 1 అంటే 5890 in lambda d by small d. Entara?
Yes.
Should be equal to
How did we get that?
Now my intention is, see, this is a screen. These are the two slits, okay? Center. This is 2, okay. Light is coming and this. See, up to what order can be seen another. Correct?
Yes.
Suppose at somewhere, whatever you are getting the bright fringe of this, bright fringe, wherever you are getting the bright fringe, at that point if you get dark of this, then bright fringe of this cancelled by dark fringe of this. Then beyond that you won't see. Okay, now? But I want question I want to do. Up to what order fringes can be seen? कितना order तक of fringes दिखते हैं? Let us say nth order of what? Lambda 1. This is bright, coinciding with what? What is the condition? Coinciding with dark of lambda 2. So what is the nth order of lambda 1 across the nth order? N lambda 1 d by small d. Dark across the dark condition ఏంటి చెప్పు? 2n minus 1 కదా, ఇంతేనా? చూద్దాం. సో n అంటే ఎంత? ఇది 58, ఇది 2n minus 1. lambda 2 అంటే ఇది by 2d కదా, 58 95 by 2. Cancellation వస్తుందా? కలిసి వస్తుందా? చూడు, 5 తో పోతుందా?
Yes.
5 1s 3 9. ఇది
8.
5 అంటే 4 కదా, 8 ఉందా?
8.
ఇది
1179.
5 1s ఎంత? 3 7 35 45 9. రైటేనా?
Yes.
ఇంకా పోతుందా? Huh?
No, sir.
So ఎంత వస్తుంది 2 అంటే ఇది ఎంత రావాలి ఎంత వస్తుంది వాల్యూ 2n into 1178 is equal to 2n minus 1 of 1179. So 2n from this 1179 minus 1178. 1179 కదా so 2n equal to 1179 అంటే n equal to ఎంత 1179 by 2 ఎంత 2 5s are రెండు ఐదుల 10 రెండు ఐదుల 16 పాయింట్ సంథింగ్ 0.5 అంటే ఇది డార్క్ అయితే బ్రైట్ అంటే 589 therefore bright is 589 bright dark ఎంత 590 dark అయితే up to what bright fringe అన్నాడు 589 first option oh mission is nice Brenda
Yes, sir.
ఇది మీ సిలబస్ అయితే ఇది అయిపోయింది వర్క్ బుక్ టైం ఉందా ఇంకా చూడు
Time up, sir.
టైం సో వర్క్ బుక్ లెవెల్ 2 పంపియానా లెవెల్ 1 మీరు చేసుకుంటారా
Yes, sir.
Yes.
లేకుంటే లెవెల్ 1 కూడా పంపియాలా
Nice, sir.
No, sir.
చలో
No, sir.
Thank you, sir. Bye, sir.
Thank you, sir.